We've already solved some exponential equations by getting the same base on both sides of the equal sign. So in example 1, we're working with a 9 and a 27, both of which are powers of 3. We can write 9 as 3 squared, and we can write 27 as 3 cubed. And then when you raise an exponent to another exponent, you multiply. So this is the same as 3 to the 2x minus 2, and this side is the same as 3 to the negative 3x plus 6. And now since we have the same base on both sides of the equal sign, we can set the two exponents equal to one another. So 2x minus 2 equals negative 3x plus 6. And then we want to get our x's on both sides, on the same side of the equal sign, and then the constant terms on the other side of the equal sign, so that we end up with 5x is equal to 8. And dividing both sides by 5, we end up with x equals 8/5. But now the problem with this method is, depending on the numbers that were given as our original bases, we might not be able to make them look the same. Like in example 2, we're given a 5 and a 7. There's no way that we can use exponents to make a 5 and a 7 have the same base. So we're going to have to approach that a different way. And that's where some of our properties of logarithms that we talked about are going to come into play. The one that we're going to be using most commonly is the one that says when we have an exponent inside of a logarithm, we can bring it down in front as a multiplication. So the way that I'm going to start example 2 is I'm just going to stick a natural log in front of the 5 to the 1 minus 2x. And it's perfectly acceptable to do that as long as at the same step I also stick a natural log on the right side of the equal sign. And the purpose in doing that is because now that I have a logarithm in front of the 5, I can pull the exponent down in front and turn it into a multiplication, so that this becomes 1 minus 2x times the natural log of 5 equals the natural log of 7. So we need that logarithm in front in order to be able to do that, in order to be able to bring the exponent down. And it doesn't matter which logarithm you use. I'm in the habit of using natural log, but log base 10 would work just as well. I wouldn't recommend using anything but natural log or common log though, because those are the two that you have a button for on your calculator. A lot of these we're going to end up with a decimal answer, and if you would use a different base for your logarithm, you would have to do the change of base formula to get to your final answer. So it's easier if you just stick with natural log or log base 10 to begin with. So now that I've got my equation in this form, my goal is to get this x by itself. And throughout all of these steps, we want to keep in mind that the natural log of 5 is just some number. It's an ugly irrational number, but it is just a number. And the natural log of 7 is just some number. So we want to treat them as such as we're going through the rest of these steps. So if I have a number on the outside of a set of parentheses, I want to think distribution. So 1 times the natural log of 5 is the natural log of 5, and then multiplying these two together will give me minus 2x times the natural log of 5, and that's equal to the natural log of 7. And now since I'm solving for x, I want to take anything that doesn't have an x in it over to the other side of the equal sign, which in this case would be the natural log of 5. So I'm going to subtract it from both sides, which gives me negative 2x times the natural log of 5 equals the natural log of 7 minus the natural log of 5. And then to get the x by itself, well, at this point it's being multiplied by negative 2, and it's being multiplied by the natural log of 5. So I want to divide by those two things to get rid of them. So that means that x is equal to all of this. If I were asked for an exact answer, it would be the natural log of 7 minus the natural log of 5 divided by -2 times the natural log of 5. But now if we want an approximate answer, we're just going to take all of that and plug it into our calculator. And you just want to make sure that you're careful with your parentheses. You're going to need a set of parentheses around the numerator, a set of parentheses around the denominator, and you want to make sure that you close the parentheses after each number inside of a natural log. So if you plug all of that in correctly, you should end up with approximately negative to 2 decimal places 0.10 as your answer. And because we're solving equations here, we can even go back and check these. If we were to go back to our original equation and plug in a negative 0.1 in place of the x, we should get approximately 7 when we evaluate this left-hand side. Now it's not going to be exactly 7 because we're rounding this answer, but it should be close enough to 7 to tell you that you got the right answer down here. Now for something like example 3, we want to first get the thing that we're raising to an exponent by itself on one side, which means we want to get rid of this 2 by dividing both sides by it. So that leaves us with e to the 5x minus 2 equals 40. And now I want to do the trick of sticking a natural log on both sides of the equation. Because what that allows me to do is to bring this exponent of 5x minus 2 down in front of the natural log of e. Now the natural log of e, remember this is understood to be base e, and since these two things match, this is just equal to 1. And 5x minus 2 times 1 is just going to be 5x minus 2. And now to get the x by itself, I need to add the 2 to both sides. And then divide by 5. So we would have that x is exactly 2 plus the natural log of 40 divided by 5, or approximately, if we plug all of this into the calculator, to 2 decimal places, you should get approximately 1.14. 4 to the 3x equals e to the x minus 2. So I'm going to go ahead and start by sticking a natural log on both sides, which allows me to bring both of the exponents down. So this is the same as 3x times natural log of 4, and this is the same as x minus 2 times the natural log of e. Again, as we set up here, the natural log of e is just 1, so that's going to go away and leave us with just the x minus 2 on the right side. Now because we're solving for x, we want to get all of our terms with an x in it on the same side of the equal sign. So I'm going to bring this x to the left by subtracting it. So that gives me 3x times the natural log of 4 minus x equals -2. And now because both of these terms have an x in them, I can factor that out. I pull that out in front. When I pull this x out, I'm left with the 3 times the natural log of 4. And then negative x divided by x leaves me with a -1. And then this 3 natural log of 4 minus 1, this is just some number that I'm multiplying the x by. So to get rid of it, I'm going to divide by it on both sides. So x is equal to the -2 divided by 3 times the natural log of 4 minus 1, or approximately, when we plug all of that into our calculator, we get negative 0.63. Then 3 to the 2x minus 1 equals 2 to the 2 minus x. So I'm going to start with the natural log on both sides, which allows me to bring those exponents down in front. And now I'm going to distribute these two numbers through their two respective sets of parentheses. So I'll have 2x times the natural log of 3 minus 1 times the natural log of 3. It's just the natural log of 3. And then 2 times the natural log of 2 minus x times the natural log of 2. And here again, we're solving for x, so we want to get all of the x's on the same side and anything that doesn't have an x in it on the other side of the equal sign. So that means I want to add this term with an x to both sides. And then since this one doesn't have an x, I'm going to add it to both sides to move it from the left to the right. So what we have at this point is 2x times the natural log of 3 plus x times the natural log of 2 equals 2 natural log of 2 plus the natural log of 3. And then here I'm going to do something similar to what I did in the last example. Since both of these terms have an x in common, I'm going to factor that out. And that's going to leave me with 2 natural log of 3 for the first term, and then just the natural log of 2 for the second term. And again, this 2 natural log of 3 plus the natural log of 2, that's just some number that we're multiplying the x by. So we're going to divide both sides by that number to get rid of it. So x is approximately, when we plug all of this into our calculator with lots of parentheses, we end up with approximately 0.86 as our final answer.